Hello everyone, let's start our lesson. Today we are going to talk about the international system of units. So in the beginning, I want to ask a question. Why do we need SI units? I think the answer is simple because we can have united standard major themes. 像是这一张图啊，基本上它有两个长度的单位，一个是英寸跟英里。那我们到底要怎么知道谁比较长？然后或者是这两个单位它们差多少呢？ So this is the reason why we need to united standard. We need to have a united standard. It will make calculations very fast. So there are 7 SI units. It is time, length, mass, amount of substance, thermodynamic temperature, and luminescent intensity, and electric current. So it is a symbol of physical quantity here. So there's a problem now. The symbol of quantity M is for mass, but the symbol of units M is for length. So in order to tell it is symbol of quantity or it is symbol of units, we will add a parenthesis in units. Okay, so remember, if there is a parenthesis here and it's about units, okay, so I think it's easy to tell it's a symbol of quantity or a symbol of units here. Okay, and to make you remember those 7 units, let's see this picture. So let's say you are doing an eye exam. Okay, so please imagine there are 7 SI units in this room. Okay, so I think some students will think it is hard and it is difficult, but please try your best. First, there is a clock, so it's about time. And the door or desk and laptop, it has a length and mass. So now we got time, length, mass now. And here is a glass of water. A glass of water is like if you have 180 gram. Okay, so it's about 10 mole. So 10 mole is about amount of substance. And the temperature of this water, of the glass of water, is a room temperature. So now you got temperature. The room temperature is about 300 Kelvin. Okay, and now here is a chandelier, or you can just say, how can you use the laptop? The laptop, you need to have a battery. A battery will produce electric current. So you got electric current. And here, the chandelier, if we or press the button, and the chandelier will shine. It's about luminescent intensity. So yes, it indeed has 7 SI units here. Okay, so I think you can imagine and it will help you to remember these 7 units in your daily life. And let's see the definition of second. In 1964, the second was officially defined as the duration of this huge periods. So let's say it's about 9.2 times 10 to 9 periods of radiation corresponding to the transition between 2 hyperfine levels of the ground state of cesium 133 atom. Okay, don't worry, I know you are wondering what is transition or what is ground state, and we will introduce it in chapter 6. Okay, so all you have to know is second now is defined as a nature frequency from atom. Okay, and what is definition about the meter? Okay, so a meter was once defined as the distance from North Pole to the equator. and it's not precise because it's about 1/10 millionth of this distance. But now the meter is defined as the length of the path traveled by light in a vacuum during a time interval of about 1/300 millionth of a second. Because the light speed is a natural constant, so I think it is more precise than a previous one. Okay, and next one we will see the definition of kilogram. We know the kilogram was once defined as the international prototype of the kilogram. Okay, so in Chinese, we can understand it's about 博音合金. We don't want to use the less artifact because it will have some oxidation, or you will lose some mass when we wipe it or clean it. So now we want to have a natural constant to replace it. So now kilogram is defined as a natural constant. It is the Planck constant. And this value is tiny, or you can say it's smaller. Okay, it's 6.626 times 10 to minus 34 joule second. So now the international prototype is retired. Okay, if you are interested about the last artifact, I mean the prototype, and you can scan this QR code and see the movie. Okay, it's about 1 hour. I think it's interesting because a lot of scientists work on it and replace it to use the Planck constant to define kilogram. So now redefining the SI unit in November 2018, the world's measurement experts voted and unanimously approved a revision of the SI. So now the 7 SI units are all based on physical constants of nature. So like here, the kilogram correspond to the natural constant is the Planck constant, and the mass corresponding to the light speed, and the ampere corresponding to elementary charge here. Okay, so after introducing the definition and the 7 SI units, so now let's practice about the derived quantity. So what is derived quantity? Derived quantity is composed of SI units, or it can compose of SI units only. So let's do some practice about some we are familiar in our junior high. So the first one is area. And we can understand the definition of area. I think it's easy because the area is about the length times width. So the unit of length and width is all meter. So the unit of area is meter times meter. So it's equal to meter square here. And the volume, okay, it's about the length times width times height. So I think those unit is all meter. So the unit will be cubic meter. Or you can just say meter cubic. And the density is about mass of an object per unit volume. Okay, so it's defined by mass per unit volume. So you will see the units it's kilogram per meter cubic or meter cube. Okay, so this is the area, volume, and density. Their unit is is composed of SI units, and it is derived quantity here. So let's see other 4 derived quantity. So first one is a velocity. Okay, velocity is defined by your displacement per unit time. Okay, or you can say change in position per unit time. Okay, so we can say the displacement is the length, its length, and unit is a meter, and the time is for second. So meter per time is the unit of velocity. And what is acceleration? Okay, so I think it's hard to describe it, but if you want, you can just say it's a change in velocity per unit time. The change in velocity, the unit is a meter per second. Okay, so change in velocity per unit time, it's it's a second. So the unit of acceleration is a meter per second square. So force, okay, I think the force is hard to describe also. Maybe you can say it will change the motion of object, or it will deflect a spring, or it will compress spring, or tensile spring. But I think you are familiar with Newton's second law. So Newton's second law, the formula is force applied to an object, and the object will do acceleration, or will be accelerated. So the force equals to the mass times acceleration. So the units we usually use is Newton, but now we can say in SI units. So it's about the mass is kilogram, and the acceleration is a meter per second square. So this is composed of SI units. So I know you are familiar with here, it's a Newton, but now in SI units we will use left hand side here. Okay, so let's see the pressure. The pressure is a force applied perpendicularly on the surface of object or substance per unit area. So here I will write down it's a force applied perpendicularly and per unit area. So now we can understand the unit will be, okay, I just wipe some area here. It's a kilogram meter per second square and over a meter square. So we can obtain it's equal to kilogram per meter second square. Okay, so it is units of pressure here. So let's see the last part. Okay, I think it's also the difficult here. So let's see the definition of work. Okay, the work is the dot product of force and displacement. But you haven't learned the dot, so we will use a simple way to tell you the work is the product of force times the displacement. But the displacement, the direction is along the direction of the force. Okay, so you can say the displacement is along the direction of the force. So the unit will be, we all know the force unit in SI is a kilogram times a meter per second square and times meter. So we can get it's a kilogram times meter square per second square here. And power, or say electrical power, the unit is all the same. But power, the definition is how many work you have done per the interval time or unit time also. So it's the unit will be kilogram times meter square per second square and per unit time. So you should as a second here. So now we can understand the unit of power is a kilogram times meter square per second cube here. So somebody will think it's hard to imagine or it's hard to remember the kinetic energy and the potential energy. I know and I understand, but the unit of these two energy is the same as work, because the work is the transfer from energy A to energy B. So the unit of those three is all the same. Okay, sorry, here it's these three. It's all the same. So we can just write down it's a kilogram times meter square per second square. Okay, so it will become easier because you can connect it with the other physical quantity. It's all talk about the energy, so the unit is the same. But let's review the definition. The kinetic energy is about half mass times velocity squared, and the potential energy is related about the work done by gravitational force. So the potential energy is about the work done by gravitational force. So it's about, this is a force, and times displacement is about the height. So near the surface on the earth, we will use potential energy equals to mgh. Okay, so here is our practice about the derived quantity. Okay, that's all for today. See you. If I got something wrong, and you can tell me in comment area. So see you. Bye bye.